For this problem, I will try to graph this function. So remember that with rational functions, you kind of want to go step by step. I wrote down Hole's vertical asymptote is just VA, horizontal asymptote, slant asymptote, x-intercepts, and y-intercepts. So go through your notes and see what all of these, when does this occur? Because I'm not really going to go over it. We're just going to go ahead and do the problem. So the first thing that I want to go ahead and do is try to factor this as much as possible. Notice that on the top, I can take out a 2x, okay, and I'm left with an x minus 1 divided by x minus 3. Okay, so what I notice is that nothing cancels out. You cannot get rid of this x and this x like many of you guys were doing. That's not legal. So since nothing canceled out, then we can say that there's no holes. Remember that holes means that when I factor both the numerator and the denominator, things have to cancel out. And in this case, nothing cancels out. So there's no holes. Now, vertical asymptote, remember that in order for me to find the vertical asymptote, I need to set the denominator equal to 0. So I'm going to set denominator equal to 0. In this case, it's just my x minus 3. So x minus 3 equals 0. So that means I have in a vertical asymptote at x equals 3. Okay, so that's what I have right now. Horizontal asymptote. Well, with horizontal asymptote, let me color that in red. Horizontal asymptote, what I had to look at is the degrees of the leading coefficients, right? So the leading terms in this case, it's better to look at the ones that's not factored. It's much easier to see. You can see that the degree of the numerator is much larger than the degree of the denominator, which means that there's going to be no horizontal asymptotes, no HA. So just follow the rules that we took in class. Okay, so there's no horizontal asymptotes. However, we have to be very careful when we have the degree of the denominator less than the degree of the numerator, because we can have a slant asymptote as long as we have one less in the denominator than we have in the numerator. As you see, we have 2 here and we only have a 1 here. So that means that there's going to be a slant asymptote. Now, how do you find the slant asymptote? Well, you have to use long division. Okay, so I'm going to go ahead and divide these polynomials. So this I'm in the inside, I'm going to have 2x squared minus 2x. Notice that I have a missing term, so I have to write its place value here plus 0. Okay, just so that I have everything in decreasing order. And I'm going to divide this by x minus 3. Okay, so we're going to go ahead and use long division. I want to cancel out this 2x squared. So I'm going to multiply this by a 2x. 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. Remember that everything is going to go ahead and change signs. This is now going to be a minus. This is now going to be a positive. So this goes away. And what I'm left with here is just a positive 4x. I'm going to bring down the 0. And then I'm going to try to get rid of this 4x. So how am I going to do that? I'm going to go ahead and multiply this or add a 4 up here. So 4 times x is going to give me 4x. 4 times negative 3 gives me negative 12. At this point, it doesn't really matter what this is because we already have our slant asymptote. This part, 2x plus 4 is going to be my slant asymptote. So y equals 2x plus 4 is going to be my slant asymptote. We don't really care about the remainder. Okay. Now, x-intercepts and y-intercepts, these are helpful to draw the graph. X-intercepts, remember that we need to set the y equal to 0. Okay, in this case, our f of x is our y. So I'm going to set this equal to 0. So I'm going to get 0 equals 2x squared minus 2x divided by x minus 3. Notice that this goes away. So all I'm left with is just, running out of space. So I'm going to write here 2x squared minus 2x equals 0. It's better to go ahead and use the factored version because then it's easier to solve this problem. You don't have to use quadratic formula. So 2x equals 0, x minus 1 equals 0. So x equals 0 and x equals 1. These are my x-intercepts. So it's going to cross 0, 0, because remember y was 0. And it's going to cross 1, 0. Okay, so these are my x-intercepts.
Now my y-intercepts are a little bit easier because all I got to do is just plug in a 0. So I'm going to use my factored form. So I'm going to have 2, 0, 0 minus 1 divided by 0 minus 3. Notice that on the top I'm just going to get a 0, and the bottom I'm just going to get a minus 3, so I get 0. So my only point is just 0, 0. That's my y-intercept. All right, after all of that is done, now I'm ready to go ahead and graph this. Okay. So I'm going to go ahead and do my best to graph this right over here. So the first thing that I'm going to try to graph is my vertical asymptotes. Notice that I have no holes, so I'm good there. Vertical asymptotes, x equals 3. So 1, 2, 3. My vertical asymptote is going to be right here. Okay. Then no horizontal asymptote, so I don't got to do anything there. Long division, so slant asymptote, we already did it. So at y equals 2x plus 4, this is my y-intercept. So I'm going to try to make it a little small. 1, 2, 3, 4. There's my y-intercept at 4. Then the 2 tells me the rise over the run. Since there's a rise of 2, remember we can write this as over 1. It's going to go up 2, up to 6, and then over 1. Okay? And then this is going to be my slant asymptote. Okay, I can try to figure out what this value is by plugging in 0 into the y. You don't need to do that. This is just going to be negative 2, and that's not really necessary. Now, so we finished our slant asymptote. My x-intercepts, there's one at the origin. Okay, and there's another one at 1, 0. Okay. And then my y-intercept, well, it only goes through the y-axis at 0, 0, so it doesn't really matter. Okay, so this one's really obvious. We usually would say, okay, well, the hyperbola or the rational is either going to go here or down here and up here. But in this case, since we have the 2 points here, we know that it's going to go approximately something like this. Okay, and I can't draw. You can plug in some extra points at -1 to really make this a lot cleaner. And then because we know that the only way that, since we know it's a function, well, then we know that the other part should go up here. Okay, so it is a little bit of a long process. It can be really tedious, but you have to pay really close attention and you have to be able to take really good care with these types of problems. Okay, that's it.